welcome to the Congruence and Similarity class. This time we will be talking about figures that are similar or congruent. What is the difference between them? The difference is that congruent figures have the same size and the same shape, while similar figures not necessarily have the same size, but they do have the same shape. Okay? The first example we have is for congruent figures. We have these two triangles that have the same size and the same shape, and we know that because this symbol tells us that they are congruent. Okay? Remember that triangles are named by their vertex. We have a triangle ABC and triangle DEF. Okay? It is very important that the order of the letters is the same. We have to know the corresponding sides and angles. Okay? What are corresponding? The ones that are the same. Okay? Since we have congruent polygons, congruent triangles, that means that they also have congruent angles and congruent sides. Congruent sides are the ones that have the same measure, and congruent angles also have the same measure. So, for the order of the letters in our triangle, we know that A is a corresponding angle to angle D. Angle B is corresponding to angle E, and angle C is corresponding to angle F. While the side AC is corresponding to DF, side AB is corresponding to DE, and side CB is corresponding to FE. Okay? Every corresponding side and angle need to have the exact same measure. Okay? We could have congruent figures that are turned around. Okay? But every time their corresponding sides and angles need to be congruent, meaning they have the same measure. Okay? Let's practice with skill check number 1. Skill check number 1 tells us that the triangle QRS is congruent to the triangle TUV. We cannot see the triangles, but we know that they are congruent because the problem tells us so. Okay? Because they are using the congruent sign. We have triangle QRS is congruent to triangle TUV. And then it is asking us, what is the corresponding angle to angle Q? Okay? How will we know that if we cannot see the figure? For the order in which the letters of the triangle are written. Okay? Remember, since Q is the first letter that we have in this triangle, which one will be its corresponding angle? It would be the first letter of the congruent triangle, which is angle T. Number 2 is asking us the corresponding side of RS. RS are located as the middle and last letter, meaning that our corresponding side would be the middle and last letters of the other triangle. So side RS is going to be congruent with side UB. Okay? And number 3. It is asking us the measurement. The lowercase m means measurement of the angle S is corresponding to, it is equal to. Okay, remember that the measures of the corresponding angles are always the same. So the measurement of angle S is going to be equal to the measurement of its corresponding angle. What is the corresponding angle to angle S? S is the last letter in our triangle, so it's going to be the last letter of the second triangle, which is angle B. Okay? With these examples, you should be able to answer exercises 4 to 6. Let's see now similar figures. Similar polygons have not necessarily the same shape. They could have the same shape, but it's not necessary. But the same size, they don't need to have the same size, but they do need to have the same shape. And the symbol to show similarity is this curved line, okay? It's the same one we use for the congruence, but without the equal sign, okay? The only difference between these two signs is that this one does not include the equal sign below it. And there is a theorem. A theorem is a statement that is always true. It has been proven to always be true for any figure that is included in the description. Okay? The description states, if two polygons are similar, then their corresponding angles are congruent and the lengths of its sides are proportional. Okay? The angles have the same measure and the sides are proportional. Okay? They don't have to be the same size, but they have to be proportional. What does it mean that they are proportional? Is that you can make a ratio out of all of the sides and the ratio will always be the same. Okay, let's do an example. We have two triangles. Two triangles that have been proven to be similar. Okay? We have triangle ABC, which is the bigger one. And we have triangle DEF, which is smaller, but it must have the same shape. A, B, C, and D, E, F. For these, we have the measurement of the sides, and the angles are represented with curves. Okay? C has one curve and F has one curve, meaning that they measure the same. A has two curves and D has also two curves, meaning they also measure the same compared to each other. And B has three curves, while E also has three curves, meaning that they also are equal to each other. Now, we have the length of the sides. AB measures 6 units, BC measures 9 units, and AC measures 12 units. While DE measures 4 units, EF is 6 units, and DF is 8 units. Okay, these lines are already telling us that the angles have the same measures. So what do we need to prove now is that the corresponding sides are proportional. Okay, now what are the corresponding sides? Our corresponding sides are AB is corresponding with DE. So we are going to make the ratio. We are going to compare each one to the other. We are going to compare AB, which is 6, with DE, its corresponding side. And this ratio should be equal to all of the others. Okay? Let's also compare BC to EF and AC to DF. How do we know if all of these ratios are the same? We have to reduce these fractions to the lowest terms. What is the most that we can reduce? 6 and 4. We can divide it by 2 and we would get 3 halves. 9/6 we can divide it by 3. 9 divided by 3 is 3 and 6 divided by 3 is 2. And 12/8 we can divide it by 4 and we would also get 3 and 2. Since all of the ratios after being reduced are the same, that means that the sides are proportional. It is very important that when we are making the ratio, we use the same pattern. Meaning, if we are using the bigger triangle to go up and the smaller to go down in one of them, we have to follow the same pattern in all of the ratios. If we choose to put above the smaller triangle, we have to do the same for all of the ratios, okay? We need to follow the same pattern every time. So that is why we place the 6, 9, and 12 all above as the numerator, and the 4, 6, and 8 all as the denominator. And another important thing is that we always compare the corresponding sides, okay? We cannot compare AB with DF because they are not corresponding. We need to use corresponding sides. Now we have some examples in the skill check number 2. We have another triangle and you have to do the same thing we did in here, okay? You have to find corresponding sides, you have to find corresponding angle, and you have to find what is the proportion of the sides. So you should be able to do this on your own. If you have any questions, please log in to the Facebook Live Q&A. I hope you have a good day. Bye bye.